the development keeps on going. Next up on the checklist of things to do to make this dream into reality is developing some UI, more specifically a player health bar. My main inspiration for this is Sora's health bar in Kingdom Hearts. The character portrait gives the UI some, well, character. Other games have inspired the finished product, but that's enough yapping. Let's start developing. To create a health bar, we'll first need to create a health system. This is actually very simple, as it really only consists of two variables, the max health and the current health. Everything else is just getter and setter methods to change these values. Here is a health system that I give you free of charge. Because both my player and enemy use the same base controller, I could implement a health system for both at once. That's the power of inheritance. I have mentioned this before in my previous devlogs, but I frequently see comments asking about this, so I'll mention it here again. I did not create these 3D models or animations. They are placeholder assets acquired from the asset store and will be replaced with custom models once the project is further along. Now, onto the development. To create the character portrait, I brought the character model into Blender. After hiding the sword in the scene view, I then attached the material and supplied the character's texture as the color input. I set up a simple camera and light source for the render. I then framed the camera to capture the character's face, stopping around the shoulders. Now to render. I outputted the render to a 1024 by 1024 pixels PNG with a transparent background. After that, I created some simple shapes in Sprite to complete the UI. As you can probably tell by now, I'm going for a clean, monochrome look for my UI with simple shapes. In this aspect, I would say my main inspiration is the loading screens found in The Legend of Zelda Breath of the Wild and Tears of the Kingdom. Simple, yet stylish. I experimented with different resolutions for the portrait in Unity. I didn't want the image to be too high of a resolution as to clash with the rest of the game view, but I also didn't want the resolution to be too low either. UI elements were often some of the highest resolution images in a PS1 game. After some playing around, this is the character portrait I came up with. I wasn't happy with the result though. The portrait looked too dark. It was too different from what the character looked like in game. I went back to Blender to make another iteration of the image. This time, I set the character's material shader to be an emission shader. This made the character unlit, meaning it was no longer receiving lighting data which affected the final color of the image and the shadows the character casted upon himself. This render turned out much better and was closer to what the character looked like in game. I still wasn't happy though, so I returned to Blender one final time. The only adjustment I made this time was I changed the focal length of the camera, making the character's face look wider and less narrow. This final render closest matched my vision. With that done, it was time to create the health bar. Creating a health bar is actually really easy. To create a health bar, first create a UI canvas. Set the UI scale mode to scale with screen size. Then, under your newly created canvas, create a UI slider. First thing we're going to do is delete the handle. We don't need it. Then, we can remove the UI image on both the fill and background object. That'll give us a square slider instead of a round one. Next, on the fill object, press T to edit the rectangular bounds. Move both sides together to make a line. Next, on the background object, move its rectangular bounds to match the green area. Now we have a working health bar that goes from 0 to 100 with no gaps or overflow. Here's a simple example of how to control the slider through code. Just create a reference to the slider and set its values to whatever you like. Making the max value of the slider smaller or bigger won't change the size of the UI visually. It'll only change the max value the slider can achieve. Now we have a working health bar. For some extra feedback, I created a catch-up bar behind the main health bar. This sort of indicator can be found in games like Dark Souls. When the player takes damage, the main health bar will reflect this immediately. The catch-up bar will wait for half a second before smoothly animating itself to the same value as the main bar. This is done through a coroutine. For the last bit of extra visual feedback, I wanted the character portrait to react when damage is taken. In Kingdom Hearts, Sora's portrait changes to an injured expression. As this model is a placeholder, I didn't want to spend time creating a custom pixel art portrait that would only be thrown away at a later date. Instead, I added a red flash to convey that damage was taken. I think that'll do it for our player health bar. For the enemy health bar, I wanted to take a different approach. When I get around to making a boss, its health bar will probably stretch the top of the screen, but for this normal enemy, I want the health bar to exist in world space. I achieved this by creating a new canvas, setting the render mode to world space. I created the health bar the same way I created the one for the player, only this time, the health bar appeared in the world, and not just locked to the camera like the screen space UI. World space UI elements are basically like cardboard cutouts that exist in a game world that can be seen from all angles. I don't want the health bar to be seen from all angles though, so I created a script that made it follow its owner and always rotate towards the camera. Drakengard contains a toggle for these health bars, changing their visibility in the world while playing. I think I'll add that feature to at some point, once we have a bit more going on. That'll do it for the normal enemy. Lastly, to make the game begin to feel like an actual game, I made it so both the player character and enemy character can now die. Since I haven't decided on what the death screen will look like yet, I made it so the player can no longer move the character and the enemy stops attacking. When the enemy dies, I detach the model so the animation can play without interruptions, then deactivate the enemy object, removing the collider and particle effects from the world. These things are all very simple on their own, but when put together create something visually and mechanically engaging. That'll do it. Don't worry, we'll get back to developing the Dragon controller soon. There's just a few more things I want to get done first. If you're enjoying the development of this project, then make sure to subscribe so you don't miss out on future devlogs. I'll try not to have so long of a gap between future devlogs. Don't take the lack of updates to mean that no work is being done. Rest assured, work is always being done, whether it's writing code or writing the story. I'll be back soon, but in the meantime, remember this: Sic Parvis Magna.